Hi all. Today we're going to take a look at regression, which is exceedingly important for the purposes of this class because the regression that you're going to learn today and in next week's video is ultimately going to be what you do in your final paper. That's why I was so strenuous in making sure that the dependent variable that you chose was continuous, or at least most of the way to continuous as we would describe it. So we're going to go through today and talk about how to run a regression and also, more importantly, how to interpret a regression. I think the interpretation of regression is very, very, very easy. And I'm going to show you why that is. The primary thought behind a regression is we're going to predict a line. We're going to fit a line to a graph. And we might be doing that in multi-dimensional space, depending on if we're doing a multiple regression or not. But the equation that underlies it is an equation you already know. Y equals ax plus b. You know the equation already. And so figuring out how to interpret that should be pretty straightforward. So we're just going to run a very basic regression to start off, a two-variable regression, just to look at the moving parts of the table before we start adding more variables on. So we're going to look at how much democracy affects a country's conflict, with the assumption being that the more democratic a country is, the less conflict they will have generally. So this is the typical output for a regression. There's a lot of moving parts here. It's a very busy table, but I want you to focus on just a couple of things. So number of observations should be sort of explanatory. Your number of observations are 161. First off, you look at your first variable, which is your first predictor, and you can see that the probability is below 0.05, so we know that's statistically significant. We also know that this variable has a negative effect. So what that means is, as democracy increases within a country, conflict goes down. So democracies are less likely to have conflict. And how much of the dependent variable is explained by the independent variable is known as our R-squared measure. And since we're just doing a two-variable regression, we can use the R-squared as opposed to the adjusted R-squared. And so what we see here is about 24% of the variation in the conflict index is explained by this level of democracy. So what does this mean? The substantive interpretation is, for every 1 point increase in this democracy index, conflict reduces by 0.10 points. So let's look at these two variables a little bit more in depth so we can sort of see what we're talking about. So we want to look at how this conflict index is measured. So you can see it is a continuous variable that ranges from 1 to theoretical cap of 4. So for every increase of democracy, you are likely going to go down in conflict by almost 1 point, or let's say 1.11 points, which is a fairly significant decrease. So let's look at how this democracy scale is measured, and so it'll give us a better idea of like what this movement looks like. So as you can see, the scale ranges from 0 to 10, 10 being fully democratic in terms of polity scores. So how would you figure out, in theory, what a country that had a 10 on the democracy score would look like in terms of its conflict interest index on average? So we have 10, and we're going to insert in the equation. So I'm just going to put the regression back up and we say, let's say this country is 10. So what we're going to do is just plug 10 into the equation. So we're trying to solve for y. So what would the conflict index be? Well, that would be So it's AX plus B, remember that. So I'm going to type up the B first. The B is the constant. It's also known as the y-intercept, and you'll see that when I plot this. So we're just going to round this up to 2.40, and we're going to add it to 10, so 10 times, so AX, the effect of X, 10 times negative 0.11. And this will give us our value on the Y variable. Conflict of 1.3. That's what it's telling us. So on average, a country that has a polity score of 10 is going to have a conflict score of 1.3. So very low levels of conflict. Let's take a look at what this looks like in terms of graphically represented. So the way we're going to do that is with a two-way graph. We're going to do a scatter plot between conflict and polity. So that's going to simply throw out variables in terms of, or throw out scatter plot points in terms of where the individual cases are located. And then we're also going to do something called LFIT. And this LFIT is going to draw a line, the best linear fit that the line could draw that summarizes the data. And so the variable names will be exactly the same again. So this is the best line that summarizes this data. So as you can see, where this line crosses the y-intercept is this number, 2.39, which is exactly where this line would cross the y-intercept. Also, remember how we calculated what the average score would be for a country with 10 on the polity score. That is right where this point is. So as you see, all of these data points, I think there were 30 of them if I remember, or 10 of them. No, 30. All of these data points, if you were to average them, would be this point on the line, so 1.3. So this graph gives us a lot of information. It summarizes a lot of data, and that way it's actually a very good way to actually graphically represent the relationship that we're looking at. So this is a very basic two-variable regression. Adding on to the two-variable regression, adding a control variable is actually very easy. And so the variable that we're actually going to add in this context is trade percent. So higher the GDP. So we're just going to page up to this, and we're going to add trade percent GDP. So as you can see, the command hasn't changed at all. And the important part is the interpretation absolutely doesn't change at all. One sort of caveat to add. Instead of using the R squared, you'll now use the adjusted R squared when you're doing a multivariable regression. And the reason for that is the adjusted R squared penalizes for added variables. So you can see that in this case, the R squared is different from the adjusted R squared. So we say with the adjusted R squared is a more accurate measure. I would caution, do not compare R squareds or adjusted R squareds across different model configurations because they're simply not meant to do that. The R squared is a summary measure of the model you're actually looking at, not a tool to compare across to other models. So just don't do that. So what have we learned here? Well, we've learned that this polity score is still statistically significant, but the effect of it has gone down a tad as we control for this trade GDP, percent GDP, which is also statistically significant. So we know that this variable, the democracy variable, ranges from 1 to 10. We already checked that out. And we know our dependent variable ranges from 1 to 4 continuously. How is this trade percent variable measured? Well, we know it's continuous, so we're just going to look at the summary of it this time. All right, so it ranges from 12 21.12 to 419.47. So that's probably measured in millions. So let's try to figure out the predicted value for y. So let's say, again, we'll take 10 as our policy score, so the most democratic you could be, and we'll literally take the mean for trade percent, so 86. So let's again solve for y. So we have 2.7 plus 10 for the policy scores, negative, we'll say 0.1. We'll do 86 times 0.005, or negative 0.005. So this should get us the average y value, so the average value on conflict for a country that has the highest score possible on democracy and also the mean score on trade percent. So in essence, we're going to control for this score by making it the mean and look at the effect of this score. So this will give us the predicted y, which would be 2.17. And so this effect of trade percent, as trade percent goes up, democracy or conflict goes down. So if you have a high democratic country with a high trade deficit, you would expect low levels of democracy. We can also plot this, but we can plot this in a much more interesting way. And that way is by using the control variable, in this case, this trade percent, as an analytic weight. And as you can see, by putting it as the analytic weight and making it a circle, what that's going to do is that's going to adjust the size of the circle to actually make it represent comparatively the magnitude of that variable. So you can see we have a lot of circles. What the size of this circle represents a very high trade percent GDP. So what we have is the same X and Y relationship. So polity predicting conflict, but we also can see the control values here with regards to the size of GDP. And so you can see when there tends to be more conflict, there tends to be smaller GDP. So you can see that that's also an effect going on in this area. So this is a really useful way to sort of visualize our data and to see what it actually represents. So in terms of your final paper, what I'm going to expect is a regression with control variables. You can add multiple. We could add more control variables to this example, but they're largely unnecessary just to sort of teach it out. Because the way that you would figure out the value of a y, your expected value of y, would be simply to do this regression and add more variables. As you can see, this AX part of the equation is the quality, the value of X and the effect of X. And that's what this coefficient is the effect of X. So you can calculate any number of variables with regard to the effect here. So I think that this is pretty straightforward. The only real caveat that I'm going to add is what this looks like going forward when you're working with weighted data. So we're going to go ahead and go into the GSS here for a second. So let's just look at this basic example. Since we've already done multiple regression, we'll go this route. Oh, these are supposed to be brackets. I always forget that. So as you can see with the probability weight, what we find is that, again, you'll notice it doesn't give us an adjusted R-squared despite the fact that we have multiple variables. That's okay. We're going to calculate one in just a second, and it's actually very easy to calculate one, but that's just a function of the probability weighting. So as education goes up, and we see that education is statistically significant, as education goes up by 1 year, you're more likely to be lenient in terms of opinions towards abortion. And the same role, as you get more liberal in terms of your interpretation of what a woman's role is, you're also more likely to be supportive of less restrictions on abortion. That's generally how you would interpret this. And you could go through and calculate the expected value of Y given a value of education and value ephemeral in exactly the same way that we did for the previous example. Now, how do you get this adjusted R squared? All you do is, I'll do it exactly as the book showed it. But it's very easy. That's the equation. So just calculate this. You have to type it immediately after the regression. You'll see that our adjusted R squared is 0.11 really, so 0.09. So it's not that affected by adding an additional variable. But this is the way in which you do this week's homework, and it's generally the way in which you will do your final paper, simply adding more control variables. This should be, I think, very easy, but this is actually what we've been building to this entire class. So if there are any questions, please throw them on the message board. But you are now fully equipped to be able to do the homework for this week and also start working on your final modeling choice in terms of variables for your final paper. All right. Have a good weekend and stay safe.